Nice to see you. Welcome in my garden. I'm very happy to invite you, make a tour of the garden. As the story of watchmaking in Switzerland is always binded with the farmers, I am living in an old farm that is 450 years old. A very beautiful sightseeing there. You have the lake of Neuchâtel Lake, Lac de Neuchâtel. At the end of the garden, just over there, you have some bees. Yeah. This one was just started in April, end of April. It was very small, and we start again to grow a new colony. In this, during this time, the springtime, you can have up to 50,000 bees per house. So it's a huge number of life. Last year, for example, we have produced 20 kilo for the whole year with 4 houses. And this year, we are only at the half of the season, and we are already at 60. No, it's not a business. But this house who choose us. The story is very, very special, very nice. But the guys who give me these files give me a second file, and I ask him, but why do you give me a second one? Yeah, that's another house, you will see, but I don't just want a house, I want this one. Take the 2 files and you will see. So I took the 2 files, and when we see these houses, okay, perhaps it's good. So it was good. Yeah. That's my office. Summer office, you know, during the coronavirus, it was very, very difficult and impossible to get out of the house. We needed to stay at home as much as possible, so we've made home office.
Okay. I can imagine that's an easy place to stay. Tell us a little bit about your background.
So, my background is starting in Geneva, and I was unable to choose in which direction I want to go in my life. Even it was much more easier than today, because the choice you had at this time was less than what you have now. But so it was a bit difficult, and my father told me, okay, now you go there. That's an entry point for the engineer school of Geneva after. So you go there, and after that you can do the engineer school. So I said, okay, why not? And there, that was the watchmaking school of Geneva. So I didn't choose to be a watchmaker, but I appreciate a lot to be a watchmaker now. Yeah.
You came there by engineering, more or less.
Yeah.
Okay.
Yes.
And then?
So then I do my school in Geneva, engineer school also in Geneva, and then you need to find a place to work, an industry. So it was when we start this training with my wife, because I know my wife there also. People are telling us, what are you learning now? I am doing the school, watchmaking school in Geneva. Watchmaking school, okay, you are learning to be a working poor.
Because at this time nobody got a job.
Yeah,
okay.
That was in the 85.
Okay.
1980.
Not the best outlook for a job.
It was the big drama of the watchmaking industry in Switzerland. There were 90,000 workers, people who were working in the watch industry, and it was going on to less than 30,000. 25.
Two-thirds lost the job.
Yeah, lost the job. And what are you doing now?
And you choose that. Okay.
I didn't choose. I jump into.
Okay.
Yeah. So
so where did you actually get your first job?
So we try to find a place where we can work, both my wife and me. That means you need to find a big company, and we try to find one on the place of Geneva, because we were from there. But okay, nothing appeared to be good for us and available, or I don't know what, but we saw a small head in newspaper that ETA were
I heard of that company.
Yeah. That Hayek father was just buying the company, ETA were looking for engineers. So we said, why not learning German, learning our job, how really to make a...
So wir können auch Deutsch sprechen. We could.
We could.
But we don't do that. If you want to speak German, you just continue.
It took me 20 years to try to speak German. You know,
I stick with English.
If I jump into a technical training, it's because I was not able to learn any languages.
Okay.
Even in French. No French. So I was very bad in French. Impossible to learn German and English also.
As long as you can do a good construction, you don't need to talk too much.
Yeah, I am not sure, because a construction without communication
doesn't work.
Is nothing.
I agree with that.
Okay, so that's why.
Okay, so you started at ETA, and what kind of projects did you, or how long did you stay there?
ETA is a next school.
Yeah, it's a school for life.
It's school for the microtechnics, for the industry, parts of this watchmaking business. And that was very, very nice, because of the scale of this factory is so big. You have all the technologies, and you have all the best practitioners of these technologies inside of ETA. So it was just beautiful. I started to work in the laboratory, where we make all the tests of the novelties. So you see the first pieces who are coming, and it was the starting of the quartz history also in '85. So we were producing quartz movement, but without any control means. Everything was to be built, to be resynced, to be made.
Everything from scratch.
From scratch, yeah. So in the laboratory, it was very nice, because you get a watch, you need to produce the control means, and you check the watch, and you can see if it's good. So the mechanical parts and all this stuff for the stem mechanism and dates and all these things.
And gear train and things like that.
The gear train is not, but the other things are quite the same as in mechanical watch. So there we have had the test, but all the electronic parts, okay. It was.
So it was heaven.
Everything was
heaven for engineering.
Oh yeah. But
what was the most exciting thing you worked on there? For you personally?
There is so much. So first, because of these novelties of products, we also need to develop our measurements means. So I worked very hard in the development of measurement tools for these quartz movements. And that was very exciting also, because that was the starting of the computer. I started with a DOS 2 point something, Windows 2.11. You need to have DOS, and after that on top Windows, and after that you have Windows 98, NT, blah, 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 until now. So I worked through this evolution. It was very great. After that, it was roughly 10 years of works in the laboratory, doing some different things. I was also in charge of the laboratory at the end. But during this time, there is one guy, a Dutch, who came, and he said, I have a great idea. I can produce for you a quartz movement, but that is powered by the same oscillating weight as a mechanical watch. But instead of rewinding a spring, I make moving a generator, electrical generator, that reload capacitor and make running without end a quartz watch. You didn't need anymore to change the battery.
A little bit like spring drive?
No, because spring drive, that's a very old idea that came from the EPFL, but in very early years.
Long time ago.
Yeah, very long time. But there were no possibilities because the technology was not there at this time. So we started with something else. That the spring drive, you rewind a mechanical spring. You have no escapement and balance wheel. You have a generator that is regulated in the velocity. and with this regulation you get the time.
Yeah.
But the auto quartz system, that's something different. You make turning a generator that produce electricity you stock in a battery.
Directly.
And you use this battery to run a standard quartz watch. That's not exactly the same. The result is approximately the same. You have a watch without
It
battery.
still shows the time.
Yeah, but with the accuracy of the quartz.
Yeah. Okay.
Without changing the battery.
So it's really a generator project.
But nothing was working, you know.
Yeah.
The guys come with a beautiful idea, a very small generator that can be put in a watch, but it was not working.
Yeah.
So we needed to evaluate if we can develop something that can work around this generator.
And there's not much space in that one.
No.
So that I saw that generator.
Yeah.
It is a very, very small piece.
So
masterpiece of engineering.
I have here some very small piece. You know the skin from
swatch skin,
Swatch.
famous.
So you can make very, very thin quartz watches. But not mechanical. It's much more complicated. For example, you can have this kind of old watches, but that's much more big. So the most used mechanical watch, not most, but you can find very easily, that's a 2892 from ETA, caliber 2892.
The most
that is
26
millimeters diameters, roughly 3.6 millimeters 8. So we decided to work with this dimension and to put inside of that all the oscillating mass, generator, battery, quartz movement, everything.
And this ended up in the auto quartz.
Voilà.
Because it's called the auto quartz.
There you have a quartz movement from Longines, and there you, in the same case, you can have the auto quartz. So this one you need to, that's auto quartz, and this one you need to change.
But it was never really sold.
I will come on this story. So that's a quartz movement. You need to change the battery. So when you have so much watches, each time you say, hey, yeah, that's a good, I want to try to wear this one. It doesn't work because the battery is empty. So this one, you just need to shuttle a bit and it starts again. And Nick Hayek, father, at this time, was very, very enthusiastic with Swatch. Swatch product. So he said, that's a beautiful product. This auto quartz is a beautiful product for Swatch. So he explained us, you need to industrialize these things to be able to produce 1 million pieces per year at a price of so much. Punct. So we started to work on that. And finally, we've got this Swatch with the...
That's a Swatch auto quartz.
That's a Swatch auto quartz.
That's a rare stuff.
And that's the end of
the auto quartz.
The Omega and Tissot and Longines auto quartz history. Because Omega came to Hayek and he said, I have just a question. What is the difference between the Swatch auto quartz and my Omega auto quartz? Oh, the price.
Really?
Yeah. So Omega, even if Omega has developed, make all the design, develop the case, dials, everything.
And when was that?
Also the
advertising.
Was that?
When did they cut that off?
Very soon, at the beginning of the product. Yeah.
So and then more or less you transitioned into mechanical. So more and more into mechanical.
Yeah, that's another question. So there you have the auto quartz.
Yeah.
You spoke about the spring drive.
Yeah.
That's also some prototype that was made by Azulab.
Yeah.
And we also in ETA produce some pieces, develop this movement, and also develop a lady one that is 20 millimeters, 3.6 millimeter height, also with a spring drive system. And I think it was never commercialized. So this one is a bit special.
It's amazing how many products get stuck somewhere in an R&D department because sales can't or don't want to sell it at the end of the day. So you're a combination of what Japanese companies today market as their inventions you're kind of a combination of that.
Yeah. Yeah, the problem is when you are working only with technician people, you have a lot of ideas, but nobody care of that, and perhaps you get some price problems, an emotional problem. The problem of the auto quartz is, okay, what that's a mechanical movement, or that's a quartz movement. If it's a quartz movement, what is so big? Why it's so big? Why it's so expensive?
Yeah.
What the now you can have a green advertisement with that.
Yeah.
You say, okay, that's electronic, but you do not need any battery. That's and I try to do. I take back a movement 20 years after it was stopped.
Just
Not just. I needed to
do
rewind for 1 minute,
okay.
but after 1 minute, he works.
Yeah.
No, that's
green.
Amazing.
Yeah.
That's green.
That's green.
That's green. Yeah. That's electronics, accurate but green.
Yeah.
Also green. So yeah. So you need to. You cannot just dream as a technicians and make things that nobody care about. Or you can do that, but you need to agree that a lot of your stuff will stuck in the.
You get stuck somewhere.
Yeah.
You never. At the end of the day, engineering is the first thing which starts and the last thing which knows if it worked.
Yeah.
Kind of. You're in the beginning, at the end, at the same time. Yeah.
So.
And but then out of a sudden, obviously, the whole thing went into mechanical.
So when I started in ETA, it was the time of quartz movement, and we stopped everything. There was no more mechanical movement inside of the house, nothing else. And in 1995, it started again, and we saw that mechanical movement come back on the scene, and we needed to relearn how to produce this stuff. Everything was lost.
Because all the elder people probably they were sent to
Retired,
retirement, and no new young people didn't start the job, and it's amazing. So
it was amazing, yeah.
And just 10 years, the know-how was lost, or 15 years.
15, yeah.
15 years.
15 years, yeah. So we need to rebuild everything. So there were old constructors that were always there, but when you are 60, 65, you don't want to work.
Yeah, you don't want to do
to
the hard
push.
stuff again.
Yeah, okay. Yeah. I've done that 20 years ago. You want to restart? Do it. So we tried to restart that, and I do not exactly remember. It was in 96, 98, something so. That the ETA make a big restructuration. It was structured in a department, but in each department you were producing or working on all the categories of watch: mechanical, swatch, quartz, very low cost, everything. Every department was working on all these categories. So they decided to make a verticalization with a business unit Mechaline, one quartz, low-end watch, and swatch. And then you need to choose.
Where do you go?
Where do you go? So I said, I'm coming from Geneva. If I want to go back in Geneva one time, perhaps I need to work on the mechanical watch. Yeah. So I choose mechanical watch. And then there I worked on this rebirth. I participate on this rebirth of the industrial side of this production. It was very interesting. I learned a lot of things there, but I never forget to push new technology inside of the movement. I'm a specialist of movement, not of
the complete watch.
Complete watch, yeah. So I tried to. I was always looking all the side if there is something that can be applied to the mechanical watch, because I was working there, that come from other worlds, other branch, other technologies that has nothing to do with the watch industry. And there I heard about the Liga-Technik, lithographische Galvanisierung, Abformung. Das kommt von Deutschland, da oben.
We go somewhere, Karlsruhe, I think.
Karlsruhe, jawohl. And there is some PhD that worked on this technology at the EPFL. Hubert Lorenz. He made his PhD on this stuff, but he was not working on mechanical parts. He was working on injection mold and very thin stuff, but for injection world. And we started to make some the first mechanical movement or components with this technology, with the Liga technology. And
but the equipment was in EPFL or already in ETA?
I think it was already in Sion.
In Sion.
Sion.
Okay.
Yeah.
That's
that was the beginning of Limotech.
This Mr. Hubert Lorenz, who
that's a PhD who worked there.
Okay.
So we started. He started to work, but I was the customer and I worked with him, and we developed some real application for this technology. And after a couple of years, I convinced Hayek further that for such a group with like ETA and Swatch Group,
makes sense to invest.
Makes sense to invest and have this technology. So he tried to buy the company.
Yeah.
It doesn't work.
So he's still independent, I know.
No, he's from the Acrotech group.
Yeah, it belongs to the Acrotech,
but
Acrotech, basically not to the Swatch Group.
No.
Which in Switzerland means you're independent.
Independent. So he's independent of the Swatch Group. That's right. And that means that if he don't buy the Mimotech company, we need to implement this technology. So I was the project leader.
And what kind of components did you do? Do you still remember the first one?
For example, the easiest, that's very small springs for the rattrapante speed time chronograph. The hertz of chronograph also. Some very small
cams, kind of levers and cams,
voilà.
Things which usually is hard to make.
Right. But there it was much more easier. We face a lot of problems with the Alterungstest.
Aging test.
Aging test, yeah. And we needed to fix a lot of bugs at the beginning.
Like every new technology.
Yeah. But at the end of the day, it works good now. It worked very, very good. And we started to implement that also in the escapement problematics. And there was one very, very special escapement that was under development in ETA. That was a coaxial escapement, specific for Omega.
The coaxial we know today.
The coaxial we know today, So there was a lot of problem, accuracy, finest weights, and also the inertia of the pieces was too high. So we were not able to run at 4 hertz. We needed to decrease to 3.5, 3.5 to get the amplitude, and I propose to make these components with the Liga technology. They said it will not work. Okay, I'll try.
Okay.
You say it will not work? I'll try. I'm sure it will work. I do the components, and it was working with 4 hertz.
Yeah.
And with
do they still do it with that technology?
So nowadays, Nowadays, they implement this technology and they are producing these components.
So you really have made the way from an engineer to the quartz, emerging of the quartz technology in Switzerland, back to the mechanical in an innovative way.
Yeah, and I bring with me some electronic background technologies, and I put that there. And we also start working with the silicon technology.
At this stage was just beginning. I mean, 1992 with the Bosch process. The Liga is some kind of in this area also.
Yeah. The machine is quite the same.
Yeah, it's a similar machine. It's
just a Bosch process.
You make a mold more or less.
The etching is different, but otherwise it's
and
quite
then it started in Micro City in Neuchâtel, when they did the first parts.
Yeah.
Okay. So and how long did you stay at ETA?
20 years, exactly 20 years.
That's a long time.
I resigned the 1st of November, 20 years after I started.
Okay. And where did you go then?
Then I changed to go to Vaucher Manufacture.
That's pretty different.
Yes. When I came there, they explained me, okay, you are coming from ETA, you produced a lot of industrialized product. We are like a very small producer, manufacturer producer, but we want to be more organized and more process oriented and more industrialized. So they told me that's why we choose you.
Yeah.
Okay, I came there. I worked with Emmanuel V, who was the CEO there, and we started to make this process of industrialization. When I started there, the watchmaker, the production directors explained me that it was organized like that. When Parmigiani want a watch, take the phone. I want this kind of watch. We go grab everywhere in the factory. If we find all the components, we put all together.
Make the watch.
And we make the watch. So, and what I like to do when I start in a company is to because I am also a watchmaker, so to disassemble and reassemble the movement, to see where are the problems, what is very tricky, what works well.
We have a guest now.
Yeah, hi. And so I came to the laboratory and I took the watch, the movement. Oh yeah, that's good. And I let the movement fall down on the table like that. Oh my God. The watchmaker in laboratory jumped to the top. And he said, hey, be careful. What, be careful? That's just a mechanical movement. You can do that with a mechanical... Ooh. No, you cannot do that.
I heard that Parmigiani is not exactly cheap.
No.
That's probably the reason why they freaked out.
Yeah, when you buy a Ferrari, you know that you will be at the
sure.
station.
I mean, you are this type of engineer who really can bridge both worlds, the industrial world, even spanning into electronics, into the super high-end manufacture world.
Yeah,
and that's very rare. I mean, usually these two worlds are very much separated, and it requires very different know-how also.
So yes, I came to Vaucher with my industrialization A's background, and I needed to learn a lot of the things of the small quantities, small batch, and all this problematic of small quantities production, because when you set up a machine, you need 1 day, 2 days, 3 days. You produce 300 pieces,
and you switch it off.
That's 2 days of production, 1 day of production, and you need to switch again. So you lose a lot of time. Is it possible to do the things differently?
Yeah.
All the technology and the process we use to control, to make the quality control of the big volume production, you cannot apply that to the small production. Enfin, at this time, it was not.
The management, more or less the management of the whole.
Quality management is completely different. So is it the only way you can work in the small series, or can we find other way to guarantee the reliability of the final product, the quality of every pieces, without all these setup times and all
big overhead for industrial levels, more or less.
And it is possible. It's possible.
I mean, many people say things are not possible, but at the end of the day, if you try hard, a lot of things are possible. And I think it was given in the industry that there is a clear divide between manufacture and industrial. And there shouldn't be.
No.
Because at the end of the day, there's a reason why industrial processes are good and needed in order to stabilize quality. And there's a reason why manufacture is good, because it brings a certain beauty to the product. And
but you
both
can merge
together,
both. Why not?
Which we call industrial manufacture.
Voila.
Do you still remember when we met first time?
Oh yes, it was a long time ago. We were young.
Gray hair, no hair, gray hair.
Yeah, it was in 2006 or 2007.
Yeah.
You came to Vaucher Manufacture, and you asked for movement. And you said, hey, we've heard that the SWAT group will stop delivery. What are you doing? Do you have some movement? Yes, of course, we have this. Oh. And how much is that? Yeah, 1,300 for 3 hands.
We went pale, you know? Like
Okay. So you decided, and that's why I am always working with you now, and we are always in contact, because when you heard that, you said, hey, they are completely crazy, these guys. It's not possible. There is surely another way to produce mechanical movement in smaller quantity than ETA, I don't know, but approximately at the same price as ETA.
I mean, it was really not our plan to make a movement, to be honest. It was not our plan, but we couldn't buy anything. And we started to find out that this is a very special thing, industry, you know. And I still remember, I remember we negotiated 2 years altogether. Our first watch, Omnium, you know, we had everything ready, designed, but we didn't have movements. So first movements were ETA, bought somewhere in the gray market from a friend. And then we negotiated with you and Emmanuel Huy, and it took 2 years. And then I remember Hermes, the bag maker, bought actually a share in the company. And we got a letter, I think it was a letter, and Emmanuel apologized that you can't sell anymore to us. And then we went back to there and we had another meeting, and we were walking through the factory. I still remember, and I exactly remember the place when we were driving back from Fleury. There's a big when you go down to Colombier or this area, you know, there's a big turn. Very nice, the lake. And I told to my wife, I said, I think we can do that. I still remember. And
did you learn something about the watchmaking industry, about the movement, mechanical movement? Nothing. You just said, I'm sure we can do that.
I would say I had some other problem projects behind me already. So she was in the industry for a long time. I did some other complicated engineering projects, and I had the feeling that we should try. And we tried. And since this time we know each other, and since this time also the whole idea of doing high-level industrial engineering on a premium industrial movement product, competitive, but in a much smaller volume than usual. And that's how the K1 movement started, and you have been kind of always around. So,
because it was so courageous from your side to do that. I said, la 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 la.
Everybody said we will burn 100 million. I remember still. Everybody said, yes, it will cost you 100 million Swiss francs. That's a lot of money. I mean, you can buy a lot of these houses. And so we just tried, and then we consequently followed this, especially I think because we were at Horage Manufacture and learned about the manufacture style of anglage, polishing, finishing, and the details which goes in. And at the same time, we were in industrial supply mode already. So we did that, and we tried to merge that, and we had this engineer, and you were always kind of around, keeping an eye on us. So what are the kids doing here, you know?
No, it was not. No, never. What are the kids doing? Never. Just how are you going on this way? And if I can help you, I will help you without problem. Because if you are in this shit on this way, it's perhaps because of the decision we needed to take. So I always thought I had a kind of responsibility of what you're living. So I said, okay, I need to be there. And
then you became CEO of Horage Manufacture for a while.
And 4 years.
During crisis time, I remember.
2009.
So not the most easy time.
No.
That was the time when we launched the first product. Not the best time.
No, also that. No.
And it was at this time it was still an ETA movement, so we were far away from something workable. And then I remember you went to another company. after that?
So I worked in Val-Fleurier, that's a Richemont company who were producing movement, developing and producing movement for Richemont Group.
Mm-hmm.
And just 2 months after I was started there, they decided, Richemont strategy decided to make manufacture movement in every brand.
Okay.
So I was there without any job, and after 2 years I left.
And then you came back again. Then you started your own engineering office.
Yeah.
We can do some advertising. Florex Engineering. So if you need some products which are not easy to make, very small and fit into the area of watchmaking or electronics or anything in machining, ask him. He can help you.
I have some experience. Yeah.
So then you came back with and you helped us actually to
make the third run.
The third version, version number 3 of K1, which we then launched through Kickstarter. That's where most people know us. I mean, everybody said to do Kickstarter, I mean, crazy. But you were also part of the campaign, and there's some pictures around.
Some pictures,
And that's what we continue to do, that product, and always follow this highly modular, low volume, industrial level engineering approach. And I think this brought us, this made us survive the whole thing.
Yeah.
And because we had a very good boss, which is very hard on the cash flow.
Yeah. On delay also.
Yeah.
I want that now.
No delays.
Okay.
Cash flow and delay.
Yeah.
And
but
I mean,
without
her, we wouldn't have made it like that, because if you don't have someone which has this sense for financing, and I'm always somewhere in between, you know. And then Jonas was taking over, and you were actually
a very nice, very good job.
Jonas
he
was a lonely fighter, you know. At the end of the day, I mean, if you do that as a young technician and engineer and get through that alone, that's
you are good.
I think
you are strong,
if you wouldn't have been around, he probably, I'm not sure if he would have
survived.
Had this patience.
Yeah,
because you need someone, you know, to say, okay, keep going,
rely on.
And then we went out and we launched 3 times in Kickstarter.
Yeah, but in this third version, we improve a lot of the product.
Yeah,
we implement the silicon technology.
Yeah, silicon technology.
Improve the escapement system.
Yeah, I think we didn't plan to do that, you know, originally. But
but again,
we called someone and said, "Can we buy some escapements?" They said, "No." Okay. Then
so we do.
Well, we knew that.
Again, and the last time.
And I think that's also, I think that's a good thing. Basically, an engineering team should always try to overcome any problem which is coming along.
Oh yeah.
But there are a lot of people who say no, that doesn't work. And that's something which you will not find. And I've never seen you like that anyhow.
Because I was trained at a good school in ETA.
Yeah.
I was in the laboratory. In the laboratory, there was also the concurrence analysis product.
Competitive analysis,
We got all the product from the other companies, and we make some analysis of that.
I mean, so all the know-how of Switzerland is concentrated in that place.
So there, I was not part of the development department. I was after the development department. They come to the laboratory. We broke everything that I have developed, and we are not we are the bad guy.
Yeah.
So I am aware of that. I'm used to this position, and but end of the day, we saw everything that doesn't work.
Yeah.
We have ideas of the dimension of the scale of the things, and we all have also access to all these analyses from third parties' products. So we were speaking to the designers in ETA and give them some possible solution to their problematics. And a lot of time, the people said, "No, it's not possible."
Not possible.
Yes, I saw this. No, it's not possible. So I go back to the laboratory, get the analysis of the Psycho, Citizen, and others one, and come see that's not possible. There you have a piece like that. well, okay, if you look like that, it can be, I don't
it was
see-
lucky, some
yeah,
luck.
yeah.
Yeah.
But at the end of the day, they change their mind,
Yeah.
and that's also how I am built inside
Yeah.
my computer. My brain is so built that I always like to see other ways,
Yeah.
other possibilities to find a solution.
Unless you don't try, you don't know if it doesn't work. A friend of mine always says,
Yeah.
you only learn from failure.
Yeah.
But failure hurts like hell. And it costs
right.
money.
Yeah. Yeah.
But
No.
that's what you do. I think that's what I without this mindset you just never think about doing a movement or anything which is a little bit sophisticated. And I think this was where our friendship came together, and then and after that launching of ourselves, we were surprised that everything worked so well. Your wife also gave input on our calendar because she's a calendar expert.
She wrote the calendar manual development in ETA.
Okay.
She wrote it.
And that's a very difficult function, we found out.
Yeah.
Sounds easy, but most companies have problems with that.
To produce a movement, it's very easy if you have no tige mechanism, automatic system, or date.
Yeah. Then it's easy.
Otherwise,
yeah, now I know why some people just make hand-wound movements with two hands.
Voila.
Because the tricky stuff is really somewhere else.
Yeah.
No, I think I'm happy that we faced all the challenges and we had to figure out where are the suppliers, are they independent, can we have new technology. Now, more than 10 years later, we are lucky that we always had the problem. Because we had to overcome it anyhow. And then, and in 2016, again, your life changed a little bit. So you went into...
Yes, I was hired for 3 years in La Jouperet, Japanese company, citizen. And I worked there for 3 years.
Yeah.
And that's also a company that is between high volume and
manufacture, high manufacture, because Angelus is part of that company, and Arnold & Son, and
the most the bigger market of La Jouperet is the development of added module on the basis of the 7750 chronograph caliber from ETA. They made a huge
I saw the production equipment. It was actually designed for a large volume. But then it changed more into a module.
They were not
a lot of
really a movement producer or developer. They started to produce movement with the brand when they bought Arnold & Son and start
Angelus
again Angelus, the two brands. And then they started to develop movement specific for these two brands, with one focus, that was the design. It needs to be very symmetrical.
Okay.
So it's very easy to recognize an Arnold & Son pieces because it's you have geometrically symmetry. That's enough.
And we went into another direction, and then we stayed in contact, and we saw all these Tourbillon watches, and we made a Tourbillon watch together.
Yes, and again
we will have some surprise.
We started to work with existing products because there are some Tourbillon movement.
Yeah.
But again, because of politics and I don't know exactly why, we cannot have this tourbillon anymore. So we need to find a solution again. And again, you said, no problem. We do that.
Do that.
Do that. Okay, so we are starting now.
We learned a lot. This project was very refreshing to, I would say, when we have this K1 hard industrial thinking and then doing this for the soul, you really think about angle, look, feel, and that's very different. So
Yes and no, because it's possible to work with standardized components, put this component inside in a beautiful way, make the turbine cage that is always a bit tricky and special, because you have a lot of very small components that need to be good produced or adjusted. And after that, you need to make the decoration on top of that. So the construction need to be adapted for the decoration. So that's something a bit different. And okay, that's where the added value comes. That is in this decoration. You need a lot of time to make this decoration.
Yeah, sure. I mean, it's not rocket science at the end of the day to do that movement itself, but making it in price, in time, in quality, in look, then it's getting closer to a rocket.
Yeah.
I think we could talk forever. But
yes.
we need to come to an end.
Okay.
So thank you very much, and we appreciate very much the friendship which actually emerged out of a stalled deal trying to buy some movements, and I hope we can have another 20 years or 15 years or whatever to do exciting stuff.
Yeah, the life is, I hope that the life will be long enough to work
on a lot of difficult things.
Always and always. Yes, that's very exciting.
That's
to do the same thing every day. No.
That's a good end, I would say.
Yeah, let's go for the future. A bright new future. But if you are able to make something good with what you get, it's good. If you always want to push against the reality, not so good.